Welcome GeoTrig. This video is on 4.5, graphs of sine and cosine functions. Let's begin. So I'm going to start off with the graph of the sine function. This is y equals the sine of x. And the basic idea is this curve right here. You're starting at the origin and you go up, then it goes back down, and then it comes back up. This is one cycle of the graph of sine of x. And if you have looking at your unit circle, you can kind of relate it to the unit circle here. So if you have the xy chart, when your x is 0, your y is 0, your sine's 0. And when you're at the angle of pi over 6, your sine at pi over 6 is 1/2. So it actually manages the unit circle. Some properties of the graph of y sine x, the domain is everything, negative infinity to positive infinity. The range is from -1 to +1. These square brackets means it includes -1. So if you had the curly brackets, it wouldn't include -1. The period, so period is the length of one cycle basically, and the period is 2 pi. So if you're starting here, 2 pi, that's the length, and that cycle just keeps repeating. And the function is an odd function. We did that in a previous video. Other properties when we're looking at the graph of the equation. So if you have the equation in the form y equals a sine of b of x, where a and b are some numbers, a stands for the amplitude. That's how much it's going up and down. So if you have a high number there, it's going to go really high and really low. If you have a small number for a, it's not going to go as high. And that b value is going to affect the period size. So the way to figure out what the period is going to be is you go 2 pi divided by b. So for example, if we had the equation y equals 3 sine of 2x, the amplitude is going to be the absolute value of 3, which is just 3. It's that coefficient on the outside. That means the graph's going to go up to +3 and down to -3. Now the period is going to be 2 pi divided by b, so b is 2 in this case. 2's are going to cancel, so your period is pi. So that means the length of one whole period like this is actually pi. And then half that length would be pi over 2. Alright, so how do we actually graph the sine functions? So here's the 4 steps. The first thing, you got to figure out what the amplitude and period is. Alright, just looking at the equation. Second step, find the x values for the 5 key points. What does that mean? So if I have my graph here, and this is one cycle, the 5 key points are at all the intercepts and all the maximums and minimums. So these are the 5 key points right here. If you can graph that, you can sketch the curve. So you find those x values. And basically what you do is you start at the beginning, and then each point is 1/4 of the way through the cycle. Sometimes I do the beginning, do the whole cycle, then do half of that, then do half of each of those halves, and I'll give you all 4 quarters. We'll do some examples. So you find the y values for that, so just plugging it into the equation and find the y values. And then you want to connect the points to graph the curve. So for example, y equals 3 times sine of 2x. My amplitude we did before is 3, and your period was pi. We just did in the last one. So if I got to find the 5 key points. The first key point is right here. So I'll just do a table. How about that? So the first key point is going to be x equals 0, and the last key point is going to be the end of that. I'm going to go pi. That means I got a key point in the middle that's halfway through. That's pi over 2. And then I got a key point that's halfway here, so that's going to be pi over 4. And halfway between these two is going to be 3 pi over 4. So if you have those x values, what's the corresponding y values? Well, when x is 0, and you're plugging that into the equation, 3 times sine of 2x. So it's going to be 3 times sine of 0. Sine of 0, that's the y values. That's going to be 0, so y is also going to be 0. Now if you plug in pi over 4, that's going to be 3 sine of 2 pi over 4, so that's going to be actually pi over 2. Sine of pi over 2, that's halfway up there, that's going to be at 1. So 1 times 3 will be 3. Now the next one, for pi over 2, that's going to be 3 times sine of 2 over, that's actually going to come out to pi. Sine of pi, that's the y value at 180 degrees, and that is 0. 3 times 0 is 0. Next one, 3 pi over 4, this will be 3 times sine of 2 times 3 pi over 4, which will be 6 pi over 4, which is going to be 3 pi over 2. And that happens at -1 for the y value. That's like the straight down on the unit circle. -1 times 3 will be -3. And the last value of pi, if you're just following this pattern here, it should, end of your cycle, you should end up at the same spot for the y value. So plotting those points, I'm going to plot the first one at 0, 0. I'm going to do the next one pi over 4, and it's really hard to see in this graph. But this is pi over 4 and 3, so I'm going to go up to 3. It's about here. And I'll enable that pi over 4 3. Next one's pi over 2, 0, which is right here on this graph. And next one's 3 pi over 4, negative 3, which will be down here. And then next one's pi 0, which will be right here. So that graph wasn't really scaled well, but I got my 5 points and I can sketch the curve. You know, it's going to be these waves, and it should look like that. That's one cycle. And if you want to do more, you absolutely could. You keep going. Oops. And you keep making more cycles if you needed to. All right. So another thing, we have this idea called the phase shift. So if you have the standard form y equals a sine of bx minus c, that minus c is actually a phase shift. And we've done other graphs when we did like quadratic equations last year in Algebra 2, it shifts your graph horizontally. So it's shifting it to the left and right. So there's a lot of stuff going on here. This part where it says c divided by b greater than 0, that's if in the weird cases when you have a negative b, if negative b, and it makes it so it's actually shifting a different direction than it usually does. Usually you just do the opposite of whatever c is, right? But the negative b can kind of change that. That's why this stuff's being mentioned. But basically, if you have plus c in the equation, it's going to shift it to the left, and if you have a minus c, it's going to shift it to the right. All right, let's try some examples of that. So if I wanted to graph this one here, now I want to find my amplitude. What I'm going to do here, my amplitude is still going to be 3, and my period is still going to be pi, because a is 3 and b is 2. But now this shift, this pi over 3 is going to shift everything to the right, pi over 3. So that changes my 5 key points here. So if I'm doing my first key point, it's going to be at pi over 3. Instead of being at 0, it's going to be at 0 plus pi over 3. So my second key point, instead of last time, yeah, okay, well let's do the last one. I like doing the last one. Instead of the last one being pi, it's going to be at pi plus pi over 3 plus pi, which will be 7 pi over 3. All right? And instead of this one being, the middle one being at pi over 2, it's going to be pi over 2 plus pi over 3, which, if you're doing that and you have to combine the fractions, it's going to be pi over 2 is the same thing as 3 pi over 6, and this is 2 pi over 6, so it's going to be 5 pi over 6. Now, and halfway between these two, instead of being at pi over 4, it's going to be pi over 4 plus pi over 3, which is going to be 3 pi over 12 plus 4 pi over 12, 7 pi over 12. And in between pi over this key point here, we're going to have it was going to be 3 pi over 4 plus a pi over 3. So that's going to give you 9 pi over 12 plus 4 pi over 12 is going to equal 13 pi over 12. All right, those are a little bit more complicated this time, right? But we can still figure those out. The neat thing is, you know, you can figure out the y values in this case. We just want to graph one cycle. The whole thing's just being shifted over a little bit. So I'm going to say pi over 3 is about right here. Well, we're going to change this. This says pi over 3. This one's going to say 7 pi over 12. This one's going to say 5 pi over 6. This is 13 pi over 12. And this is going to be 7 pi over 3. So when you're just shifted over, the first sine wave is going to be, hit that point, it's going to be at the origin. Then this is going to go up to 3. This is going to go down. Let's go down to negative 3 and back up. So this is one wave of the sine function. And that's what you're looking at. It's all been shifted. And you could keep matching that pattern if you wanted to. If you want to go back this way, you absolutely could. And do that. All right, next one. So let's talk about cosine. Graph a cosine. Instead of starting at the origin and going up and down and back up, cosine starts at the top, it goes down to the bottom, and then it comes back up to the top. It kind of forms a U shape when you graph one cycle. So same thing. This is actually all the y values on the cosine graph are actually, if the x values are the angle in radians, the y value is the x value of the coordinate in the unit circle, which maybe sounds confusing, but we'll do that in class. Some properties. Domain is still everything. The range is -1 to +1 inclusive. The period is 2 pi, and it's an even function. The amplitude and period are the same thing for the sine function. So for this case, the amplitude would be 4, and your period's going to be 2 pi over pi. Wait, pi, 2 pi over pi, which would just be 2 in this case. So, and if you want to graph it, it's still the same idea. You have to find the ID, the amplitude and period, and then you have to find the 5 key parts. The amplitude's 4, and the cos and the period's going to be 2 in this case. And then you find your key parts here, and then you find the y values and connect the points to find the curve. So I could just do that right now. If you do that in this case, my first key part's going to happen at 0, since the period's 2. So the end of that's going to be at 2, and the middle is going to be 1. This is going to be 1/2, and this is going to be 3/4. No, that's not 3/4. That's 1.5. That's 3/2. So you plug in those in for x to find your y values. I would have -4 times cosine of 0. Cosine of 0 is 1, so this will be -4. Next one's going to be -4 cosine of, let's see, pi over 2. So cosine of pi over 2, that's straight up, and you're actually straight up on the unit circle, that's going to be 0. So cosine is going to be 0. Now x is -1, we got -4 times x is 1, cosine of pi. Cosine of pi is 180 degrees, and that's x value is -1, so it'll be -1 times 4 is +4. -1 times -4 is +4. Next one, -4 times cosine of 3 pi over 2. So cosine of 3 pi over 2 is 3/4 the way through the unit circle. That's going to happen at 0. So it'll be 0. And the last part, you should end up at the same why you started, so it'll be -4. If I'm plotting that, 0, wait, oops, that's not right. 0, -4 is right here. 1/2, 0 is right here. 1, 4 is right here. 3/2, 0, and -4 is right here. So because that was a -4 cosine, instead of doing a U, it's kind of like a V shape. It's upside down. You got to make sure when you graph this, you got to have these curves kind of going like this. It's a weird graph to graph. And that's roughly what you have for one cycle. The phase shift, exactly the same. Vertical shifts. So we're going to add the plus d at the end of each of these equations. Oh, there's a mention, before I get into that, sinusoidal graphs. You might hear this term. Cosine and sine functions are called sinusoidal graphs. Why are they called that? Because they form this sine wave. They're basically forming the same wave, it's just they're shifted. So for sinusoidal graphs of this form, that constant d is a vertical shift. So it's shifting the graph up and down. And we've done that for other types of graphs before, so that shouldn't be a big deal. Let's try some examples. Pause the video. Okay, graphing this. I want to ID the amplitude. Amplitude's 2. The period is going to be 2 pi over 1/2, which is the same thing as 2 pi, messed that up, times 2, which is 4 pi. Okay, so you got to find your key points here. So I'm going to draw a table. Should really leave more room next time. Oh well. So your first value is going to start at 0, and your last one is going to be 4 pi. So halfway to 0, 4 pi is 2 pi. Halfway to 2 pi and 0 is pi. And halfway between 2 pi and 4 pi is 3 pi. That works out kind of nice. So let's plug those in. So if you're plugging in 0 for x, you get 2 times sine. You're going to get 2 times sine of 0. And sine of 0 is the y value, 0. So y is going to be 0. Next one's going to be 2 times sine of pi over 2. Sine of pi over 2 is 1, so 2 times 1 is 2. And 2 pi is going to be 2 times sine of pi. Sine of pi is at 180, and the y value is 0, so 2 times 0 is 0. This next one is 2 times sine of 3 pi over 2. Sine of 3 pi over 2 is -1, so this will be -2. And 4 pi should end up where you started, so 0. Now that I got all that, I'm going to erase my work on the side. And I'm going to plot those 5 points. So I had 0, 0 for x, pi over pi 2 right here, 2 pi 0, 3 pi -2, and 4 pi 0. So plotting those points, now I sketch the curve. And it's roughly like that. There you go. Next one, pause the video. Okay, so I want to graph one period of the function y equals 2 cosine of x plus 1. That plus 1 means I have a vertical shift. And my amplitude in this case is going to be 2, and my period is still going to be 2 pi. So I'm going to kind of cheat right here. I know the graph of cosine of x, a 2 cosine of x, is kind of this curve, going like that. But 2 cosine of x is just going to stretch the amplitude. And that plus 1 means kind of my center is just shifted up 1. So I'm doing this dotted line just to help me out here. Now, when your amplitude's 2, you're going to go, the highest mark's going to go up 2, so the highest mark's going to go up to here. And it's going to go down 2, so it's going to go down to here. And I know my period's normal, so cosine doesn't start there. Cosine starts at the top. So that's going to be my first point. Pi over 2 is my second point. Down here is going to be my third point. And up here is going to be my fourth point. And last one here is my fifth point. So those are the 5 key points. This is going to give my amplitude of 2, and I had a vertical shift up 1. And it's a cosine function. So you don't always need to do the table if you get comfortable with this kind of stuff. So I'm going to roughly do this. Oh, that did not look right at all. That's pretty bad, so I want to do it again. That's better. So there's a graph of that. And we're done.